Alright, in this video we will learn how to graph quadratic inequalities that have two variables in addition to the ones that we've already learned that only have one variable. And in fact, I need you to really concentrate on what I'm about to say next, because some inequalities have only one variable, like problem number 1 only has x's, no y's. When there's only x's, that's when you know that this is going to be like a number line solution. Okay, same thing with number 2. These are number line type problems, okay, because there's no y values, only x's. That's why they say state your solution as interval notation. All right, that goes along with the number line. On the other hand, later on, when we get to problems like number 6, see how suddenly this has a y value in it. Pardon my yawn. That y value tells us that we're going to be doing some shading. Okay, it's not going to be a number line. It's going to be a shading type situation. Okay, so that's what's going to happen on like number 7 and 8. See the y value? Shading. See that y value? Shade. Okay, but if you don't see the y value, and it's only x values, that's how you know you're doing a number line inequality. Okay, let's get on with it. 0 is already by itself, so that's great. So let's go ahead and draw this parabola. We got x squared minus 2x minus 3. Okay, so table function and x squared minus 2x minus 3. Okay, let me scroll up for a minute here. Okay, 12, that's off the chart. So I like to just start with the first numbers that fit. Okay, so negative 2 comma 5. Coming from the top of the chart, negative 2 comma 5 is the first point that fits on the graph. So let's go ahead and graph this. Okay, so negative 2 comma 5 is going to go right here. And then it goes negative 1 comma 0 and 0 comma negative 3. All right, then we have negative 4, negative 3, 0. And 5, and then 12. Obviously, there's 5, but then 12 is off the graph, so I'm not going to worry about that right now. So this is our parabola. Let's go ahead and draw the parabola through these dots. All right, so here is our parabola. Now, remember, this is going to be a number line graph, so I'm not going to shade in anything. Okay, there are no y values here, so I'm not going to shade inside, I'm not going to shade the outside. That's only for problems that have a y. Instead, I'm going to ask myself, what part of this parabola am I going to highlight? Okay, I like to use this as my highlighter. Okay, the function has to be less than 0. Not equal to, just less than. So less than 0 means below the x-axis graphically. So this is the part of the graph that's going to be less than 0. Okay, those are the solutions. But we need to convert this to a number line graph when we have only x values. So let's convert this to a number line graph. Okay, so the solutions go from here to here. They go from negative 1 to 3. But we're going to need an open circle and another open circle. And we'll draw this blue segment representing all of the solutions in between, all these green solutions. So this blue represents the answer, but we just need to go ahead and put it in interval notation. And in interval notation, maybe I'll write it up here. This goes from -1 to 3. So I will put -1 to 3. And I'll put them in round parentheses to show that the endpoints are not included. Okay, that's it for number 1. Problem number 2 has one extra step. We need 0 over here. So let's subtract 2 from both sides. Interesting. Actually, both of these cancel out, don't they? So that's going to leave me with -x squared is less than 0. Interesting. So this should be easy to graph. -x squared just going to take it from the top. Whoa! Alright, -3, -9 is my first point. Okay, so -3, -9. It's going to be right here. And let's just go from there. Okay, I've got -4, -1, 0. So I've got -4, and then -1, and then 0. And then -1, -4, -9. -1, -4, -9. Okay, so here is my parabola happening. Now again, is this a problem where I'm going to be shading either inside or outside the parabola? No, there's no y value. Okay, there's no y. So when there's no y, there's no shading. If it's all x's, that's when it's going to be a number line situation. So that's what this is, another number line. So we look at this and we ask ourselves, where is the function less than 0? All right, and graphically, less than 0 means below 0. All right, below the x-axis. And you might think that this entire parabola is below 0, but you'd be almost right, except for this point right here at the top. That's not below 0, that is 0. So we got to be careful to leave out that part. So this part, let me make it bigger. This part of the function is below 0, less than 0. And this part of the function is below 0. Okay, but this point right there is equal to 0, so that has to be left out. Alright, so these green values represent the solutions, but we need to translate this into a number line situation. So we're going to have to leave out this point, so I'm going to put an open circle here because that cannot be included, alright, because that's where it's equal to 0, and we only want the parts that are less than 0. And then for this left branch, I'll put an arrow going to the left. And for the right branch, I'll put an arrow going to the right. Alright, and please understand that that spot in the middle is left empty. Alright, that didn't work out so well. You know what, maybe I'll do it this way. Spot in the middle is empty. Yeah, that's great. Okay, so and let's just go ahead and translate this into interval notation, and we'll need an interval for the left and an interval for the right. So let's see, can I put this up top? So for the left, that's -infinity to 0. Okay, union 0 to infinity. And that's your answer for problem number 2. All right, for number 3, we're supposed to use the following graph of a quadratic inequality to answer these questions. All right, so we've got this graph right here. Let's see what's going on here. All right, so number 3 is asking, where is negative 3 comma 0? Is this a solution? Well, let's see. So the where is basically, is it inside, outside, or on the parabola? Okay, negative 3 comma 0. So that's, let me switch colors for a second. Negative 3 comma 0 would be right here. Okay, that is on the parabola. It's on the border. All right, that's the where. Okay, now is this a solution? Now, you see how this border is dotted? Okay, that dotted, the fact that it's dotted means that it is not included as part of the solution set. So, because negative 3, 0 is on the border, but the border is dotted, that means that this is not a solution. If this were a solid parabola, then we'd say yes, it is a solution. But since it's dotted, we're going to say no. And we can add the border is dotted. Thus, not included. Okay, that was number 3. Now, where is the origin? Is this a solution? Well, here's the origin right here. And yes, that's a solution. It's clearly within the shaded area. Okay, so where is the origin? Inside the parabola. And yes, it is a solution. Okay, and maybe I'll add on, it's in the shaded region. Okay, number 5, where is 3 comma 2? Is this a solution? And maybe I'll put, so this was a no, and this is a yes. 3 comma 2. This is a no for sure. It is clearly outside of the shaded area. All right, it's outside of the solution region. Okay, where should we come to? Outside the parabola. Unshaded. Okay, not a solution. Okay, let me erase this little guy. Okay, now number 6. Does this inequality represent the graph? Explain why. Well, let's plot some points from this. Actually, let's not. I don't need to plot any points from this. Let's just use the graphical method. Assuming for a moment that this border represents the equation y equals x squared plus x minus 6. All right, let's assume that the border is correct for now. Okay, then when we have y is less than, is that telling us to shade above or below? All right, less is below. Okay, so if this were the situation, we would have to shade below the parabola. And if I put my pencil here on the parabola, okay, shading below would mean going down from here. And that would wind up shading out here, okay, because this is below the parabola. Okay, so this inequality cannot represent the picture that's drawn because the wrong part of the picture is shaded for this. Okay, it's shaded above and this says below. So we just have to say something like that. So here's a good answer. No, this inequality is less than, so we would shade below the border. However, the given graph is shaded above, so it cannot be represented by this inequality. Okay, like as we just discussed. And I believe that was the last problem of this lesson, so we are done. I hope this was helpful, you guys, and I will see you on the next video.